All right, let's talk about something that makes a lot of people nervous, algebra. But what if we thought about it differently? What if it's not just a bunch of random rules, but a language? Well, today we're going to learn how to speak it. Seriously, have you ever stared at an equation full of x's and y's and just felt completely lost? Like you're trying to decipher a secret code or read a language you've never seen before. Yeah, you're definitely not the only one. But you know what? Thinking of it that way is actually perfect, because today that's exactly how we're going to treat algebra, like a new language. And trust me, by the time we're done here, you'll be well on your way to becoming fluent. So where does any new language start? With the vocabulary, right? In algebra, our words live inside something called an expression. So let's dive in and learn the basic anatomy, our first set of vocabulary words. First up, the most famous or maybe infamous part of algebra, the variable. It's just a letter, could be an X, a Y, anything really, that's holding the place for a number we don't know yet. Just think of it as a little mystery box waiting to be opened. Now that variable usually has a buddy hanging out right next to it. That's the coefficient. It's the number that's attached, telling you how many of that variable you're dealing with. So when you see 3x, it's just a simple way of saying you've got 3 of whatever x turns out to be. Okay, next up is the constant. And it's pretty much what it sounds like. It's constant. It doesn't change. It's just a regular old number standing all by itself. No variable attached. So if you see 3x plus 5, that 5 is our constant. Simple. And finally, we have terms. This is super easy. A term is just one of the individual chunks of an expression. So the 3x is a term, and the 5 is also a term. They're like the individual words, all separated by plus or minus signs. So let's look at that whole expression, 3x plus 5, and put all our new vocabulary together. See? The 3 is our coefficient, x is our variable, and 5 is our constant. And those two chunks, 3x and 5, are our terms. And just like that, you've basically read your first sentence in algebra. Not so bad, right? Okay, so we've got the vocabulary down. Now it's time for the grammar. In algebra, the grammar rules are called properties. And you should really think of them as superpowers, because they let you move things around and rewrite expressions without actually changing what they mean. Our first superpower is the commutative property. I just call it the move around rule. All it means is that when you're adding or multiplying, the order doesn't matter one bit. You know that 2 plus 3 is the same as 3 plus 2, right? That's it. That's the rule. Next up is the associative property, or my personal favorite, the group rule. This one's all about who you group together first, and those parentheses tell you what the groups are. It says that if you're only adding or only multiplying, you can change the groups around, and the answer will be exactly the same. And the last one for now is the identity property, which is basically the stay the same rule. It's the easiest one of all. If you add 0 to any number, it stays the same. If you multiply any number by 1, it stays the same. It keeps its identity. That's it. All right, we've learned our nouns and the basic sentence structure. Now it's time to learn the most powerful verb in the language of algebra. This is the one you're going to use all the time to make things happen, the distributive property. So what does the distributive property do? Well, it tells us exactly what to do when we have a number right outside a set of parentheses. You have to distribute that outside number to every single thing inside the parentheses by multiplying. Let's see this in action, and I'll show you why I call it the rainbow rule. Let's say we have 4 times the group, x plus 3. First, you draw a little rainbow arc from the 4 to the x. What's 4 times x? It's 4x. Then you draw a second arc from that same 4 all the way to the 3. What's 4 times 3? It's 12. So 4 times x plus 3 turns into 4x plus 12. You just follow the rainbow. Now, one of the coolest things about algebra is that almost everything you can also undo. We just learned how to distribute a number into an expression. Now, we're going to learn how to do the exact opposite, factoring. Factoring is really just distributing, but in reverse. All you do is look at all the terms in your expression and find the biggest number that can divide into all of them. We call that the greatest common factor, or GCF. Once you find it, you just pull it out to the front. Let's try it with 6x plus 18. Okay, what's the biggest number that goes evenly into both 6 and 18? It's 6, right? So we pull that 6 out to the front and open up some parentheses. Now we just divide each of the original terms by 6. What's 6x divided by 6? Just x. What's 18 divided by 6? That's 3. And there's our answer, 6 times x plus 3. See? It's the reverse of distributing.
Just like when you're learning a new spoken language, there are a few common mistakes that almost everyone makes at the beginning. So let's talk about a couple of those. Because avoiding these little traps is how you go from just knowing the words to actually speaking algebra fluently.
Okay, this is without a doubt the number one mistake people make with the distributive property. Let's say you have 2 times x plus 4. It is so tempting to just multiply the 2 by the x and then completely forget about the 4. You see people write 2x plus 4 all the time. But remember the rainbow. You have to share the love with every term inside. So the correct answer is 2x plus 8. Don't fall for that trap. And here's one last really important warning. Remember our move around superpower, the commutative property? Well, that awesome rule only works for addition and multiplication. It absolutely, positively does not work for subtraction or division. I mean, think about it. 5 minus 3 is 2, but 3 minus 5 is -2. Totally different, so be careful. And there you have it. You've got the vocabulary, the variables, coefficients, and terms. And you've got the grammar, the key properties that let you rearrange things. You now have the fundamental tools to speak the language of algebra. And this is so much bigger than just solving for x. It's about having a powerful new way to describe the world around you. So the only question left is, what will you build with it?